All right, let's dive in. Think of this as your personal field guide to AQA A-Level Computer Science. We're going to take a tour of the whole course to help you figure out if this is the right adventure for you. So, let's get started.
So you're at that point, huh? Trying to pick your A-levels. And you're probably asking yourself, what is computer science actually like? Is it just coding in a dark room all day? Well, we're here to break it all down, show you exactly what you'll learn, and more importantly, what you'll be able to do. So why does this subject even matter? Well, the exam board AQA says it all right here. The whole point of the course is to give you skills that are valuable for real life. You know, whether you're planning on going to university or jumping straight into the workplace. It's all about connecting what you learn in class to what you can do out there in the world. Okay, first stop on our tour, the really fun, hands-on part. Building stuff. This is where you get to be creative, solve some cool puzzles, and turn an idea in your head into an actual working program. You've got to start with a solid foundation, right? You'll master these 4 core concepts. Variables for storing information, iteration, which is just for repeating things, selection for making choices, and subroutines, which are basically reusable chunks of code. Honestly, these are the absolute building blocks of pretty much every programming language that exists. Master these, and you're not just learning a language, you're learning the logic behind all of them.
But you know, great software isn't just about frantically writing code. It's a process. You'll learn the software development lifecycle. It's like a structured 5-step blueprint that takes you from a fuzzy idea to a polished working solution. This is exactly how professionals in the industry tackle huge, complex projects.
You'll also discover there's more than one way to think about writing code. First, there's the procedural way, which is kind of like a step-by-step recipe. Then you'll dive into the really powerful stuff, the object-oriented paradigm. This is used everywhere to build complex software by creating digital objects. It's this kind of thinking that lets developers build and manage the massive applications we all use every day.
Okay, next stop, we're going under the hood. Because just writing code isn't enough. A true computer scientist really needs to understand the machine itself. This is the theory that makes all the practical programming possible in the first place.
Now, the single biggest idea here is something called abstraction. It sounds complicated, but I promise you use it every day. Think about a subway map. That's a perfect example of abstraction. It hides all the messy, unnecessary details of the actual streets above and just gives you what you need to get from A to B. Computer science is literally built on this powerful idea.
You'll get right into how processors are actually designed. You'll compare the 2 main ways they're built, the von Neumann architecture, which is the workhorse inside your laptop, and the Harvard architecture, which you'll find in specialized systems where speed is absolutely everything.
And get this, your computer is doing this millions of times every second. You'll learn the fetch-execute cycle, this fundamental 3-step rhythm that every single processor follows to run your programs. Fetch, decode, execute. It's the heartbeat of the machine.
Okay, so you can build programs, and you understand the theory. The third part of our tour is all about connecting those skills to the incredible technologies that are shaping our world right now.
And this is where it all clicks together with the tech you use every single day. You'll explore a huge range of modern topics, everything from how massive databases store the world's information to the basic ideas behind AI and cybersecurity, the challenges of big data, and even totally different ways of coding, like functional programming. It's a real tour of the cutting edge. Take big data, for example. It's a buzzword everyone throws around, right? Well, you'll learn what it actually means. It's not just about the size or volume of the data. It's also about velocity, how incredibly fast it's all streaming in, and variety, the fact that it comes in all sorts of messy, unstructured forms.
And this is so important. The course goes beyond just the technical stuff. It really makes you think about the bigger picture. Because as a software engineer, the code you write can have a massive impact on society. You'll explore the moral and ethical responsibilities that come with having that kind of power.
So, the final part of our tour. How do you prove you've mastered all this? Well, don't think of it as just an exam. Think of it as your final challenge, a chance to really showcase everything you've learned.
The way it's graded is broken down into 3 main parts. You've got 2 exams, and they're each worth 40% of the grade. Then, a practical project makes up the final 20%.
The whole assessment strikes a perfect balance between practical skills and theory. Paper 1 is an on-screen exam where you'll actually be solving problems with code. Paper 2 is a written exam that tests all your theoretical knowledge. And then there's the NEA project. And this, for so many students, is the absolute highlight of the course. It's the non-exam assessment, or NEA.
It's a major project where you find a problem that actually interests you, and then you get to design, build, and test your very own software solution for it.
And the possibilities here are just incredible. You could build a computer game, an app for your phone, a website with dynamic content. You could even dive into solving a complex problem with AI or build a control system using a device like an Arduino. This is your chance to take everything you've learned and build something that is 100% yours.
So that's the tour. You've seen the map of the A-level computer science journey, from the fundamentals of code, to the ethics of technology, and finally to building something of your very own. The only question left is, if you decide to take this path, what problem will you solve first?